Alright, this is 6E notes. We're going to be looking at first the properties of rational exponents. They're the same properties that we dealt with in Algebra 1, but now we're going to have fractions to deal with. It's the rational exponent part of it. Okay, so look at the first one. If you're multiplying binomials, you're going to add the exponents. So we're going to have, the base is still going to stay the same. Now to be able to do this, you have to have the same base. So 4 and then 1/2 plus 3/4 is 4/2, which is 4 squared, which is equal to 16. Alright, a power to a power, you're going to multiply your exponents. So we're going to have 5/2 times 2, which makes 5 to the 5th power, which is 32. Alright, if our bases are not the same, and we're going to raise each base to the same exponent. Now you have a choice here. You could multiply the 16 times the 4 first, but if we're doing this without a calculator, we're going to keep our numbers small. We can also like distribute, wrong terminology, but kind of that 1/2. So 1/2 means square root, so the square root of 16 is 4 times the square root of 4, which is 2, so our final answer is 8. Alright, recall for number 4 that a negative exponent means to take the reciprocal. So 25 to the negative 1/2 becomes 1 over 25 to the 1/2, which is the same thing as the square root of 25, which is 1/5. And part B of that, same thing, take the reciprocal. So we have 25 to the 1/2, which is the square root of 25, which is 5. Alright, we're dividing and we're raised to a power. We're going to raise the numerator and the denominator to that same power. And the reason it says b cannot be equal to 0 because we can't divide by a 0 value. Okay, so we have, remember this is the same thing as the cube root of 27 over the cube root of 8, which is 3/2. And then final property, if we're dividing with the same bases, we can subtract the exponents. We've got to have the same base to be able to do this though. So we keep the base, subtract 5/2 minus 1/2 is 4/2, which is 3 squared, which is 9. Alright, so like I said, being able to do well in this unit is that you know these properties, backwards and forwards. Know these properties well. Another way of looking at these properties is using PEMDAS. Okay? So I always think of the exponents, they're a step behind the problem. So if you have exponents, so like a problem like this, power to a power of exponents, you're going to be multiplying. So we're going down one. You're multiplying your exponents together. If the problem has multiplication in it, like this question, we're going to go a step down. We're going to add. If a problem has division, our exponents are going to go a step down and we're going to subtract. So that's what I mean by using PEMDAS on this. Alright, let's get into the types of problems we're going to be looking at doing here. Alright, so here's our first one. It says sample 1, rewrite a simplified rational exponents. That means we want fractional exponents. Alright, please make sure you write down my bullets. So take a moment if you need to stop the video, stop and write down the bullets. Because these are the kind of the steps that you need to be thinking about, rules you need to follow. Alright, so look at the first one. Always rewrite numbers with the lowest base. So if we have 4, we want to rewrite this as 2 squared. So in our problem, we have 8. So what I want to rewrite, think about the lowest base. I can rewrite 8 as 2 to the 3rd power. This is going to help me when I simplify. Okay? Alright, bullet number 2. Change into rational exponents. Alright, so let's go about doing that. So index of 6 is going to become to the 1/6 power. Now we're going to apply our properties. So this is a power to a power, so I'm going to multiply my exponents. So this becomes 2 to the 3/6, x to the 3/6, and y to the 8/6. Now because they ask us to leave this answer in rational exponents, we're just going to simplify these fractions. So our final answer is 2 to the 1/2, x to the 1/2, and y to the 4/3. Okay? So change into rational exponents and then use our properties and simplify. And you need to follow the direction. Follow the direction how they ask you to leave the final answer. All right, let's look at another one. All right, 7. So first of all, look at this coefficient 7. We can't break down 7. Okay, so we're going to have 7 to the first power. All right, we're going to change here again, change into rational exponents. So I got x to the third, y to the fourth. All right, that was a square root, which becomes 1/2. I already had the 5 out there. So that means this all is going to be raised to the 5/2 power. All right, because this became 1/2. Square root's 1/2. All right, now use your properties. Power to a power are going to multiply. So 7 to the 5/2, x to the 15/2, and y to the 20/2, which is 10. So there's my final answer because I was asked to leave it in rational exponents. All right, more often than not, though, you're going to be asked to simplify and leave it in radical form. So rewrite as a simplified radical form. All right, here again, write down my notes. So if we have an exponent, a rational exponent that's an improper fraction like we do here, okay, we're going to rewrite this as a mixed number. This is an easy way of thinking about doing this to simplify it. Now, my little motto is whole numbers come outside, fractional and exponents stay inside. So let's rewrite this. So the first step I'm going to do is rewrite my exponent as a mixed number. So that's going to be x to the 1 1/4. Now I can separate this into x to the first, x to the 1/4. Now I want my final answer to be in radical form. 1's a whole number, so that x stays out. 1/4 gets an index of 4. So that's simplified. You're looking for how many groups of 4 you have in 5. Okay? That's why we changed it to a mixed number. All right, let's look at another one. All right, let's do something like this. First of all, you notice, like I said, I wanted in radical form, simplified radical form. Right here you're only allowed to have one index. So here I have an index of 2 and an index of 3. That's not going to be something, we can't simplify it that way. We got to rewrite these with all the same denominator. What's my least common denominator between 2 and 3? Hopefully you said 6. So I'm going to rewrite all of these with a denominator of 6. Okay, so what do I need? 2 times 3, so 3 times 1 is 3. 3 times 2, so I need a 2. And then 2 times 3, so 1 times 3 is 3. All right, now look at these. None of these are improper fractions, so I can leave those alone. That means everything is going to stay on the inside of my radical when I'm done. If we had an improper fraction, that means something's going to leave. Something's going to leave the radical. All right, rewrite, because they ask us in our radical exponents, our radical notation. Index is 6. We're going to have 2 to the third power, x squared, y to the third. Well, the numbers we want to simplify as much as possible. So our final answer is going to be the 6th root. Don't forget to write that little 6. 8 x squared, y to the third. All right, so like I said, please make sure you write down what's in blue. To simplify, you must have only one index. Everything has to have the same index. One radical. You're only allowed one radical. All right, let's put all of this together. This is where we're going from. All right, here again, write down my steps. So first thing I want to do is look at my coefficients, my numbers. Simplify the coefficients. Then I'm going to change everything to a rational exponents. Then I'm going to use the properties and simplify. So those are my 4 steps. I'm going to go through each one of these. All right, so the first thing I want to look at is 141 and 147. I'm sorry, 441 and 147. Look to see if they divide into each other first before you start breaking anything down. Well, 147 goes into 443 3 times. So I can make this 3, m to the 5th, n to the 7th, over z to the 6. All right, at the same time, I'm going to change that square root to a 1/2, to the 1/2 power, so I can use my properties. Now, remember there's a 1 with that 3. All right, so let's use our property, power to a power. So I'm going to multiply my exponents. So I have 3 to the 1/2, m to the 5/2, n to the 7/2, all over z to the 6/2. All right, now simplifying time. You're looking for improper fractions. Well, the first thing you should notice is that this can simplify to 3. So that means that z to the 3rd is going to be completely out of the radicals. Since this started off as a radical, my final answer should end up as a radical. But however, 5/2 and 7/2, they can be rewritten as improper fractions. So let's start working on this. So I've got 3 to the 1/2. M, I'm going to make that, 2 to the 1/2, 2 and 1/2. N, I'm going to make it 3 and 1/2. And all over z to the 3rd. All right, now we've got to say who goes in and who stays out. Inside radical, outside radical. And notice that I have the same denominator. I have a square root. We're only allowed one radical. Okay, so get your square root ready. Where's the 3 go? Well, it's a fraction, so it's going to stay inside. 3 to the 1st is 3. All right, look at the m. The m squared comes out, but the m to the 1/2, the m stays in. All right, n to the 3rd comes out, and an n stays in. And in my denominator, z to the 3rd, that's a whole number, so that z is outside the radical. So there's my simplified expression. So here we're applying a lot of different properties in this. That's why these are a little challenging. So make sure you ask questions when we get to class if you don't understand what I've done. All right, let's look at some more. All right, take a moment and copy down this list. So when we simplify completely, we got to make sure we have our final answer follows all of these restrictions. So we can't have any perfect squares underneath the radicals. We're not allowed to have any negative exponents. We can't have radicals in the denominator. And we can have no improper rational exponents. And remember, we're going to rewrite our final answer in radical form. So if you need to, stop the video if you need more time to write these down. But this is what you need to know when I say simplify completely. This is what I'm asking you for. All right, another problem. All right, let's do this. All right, I see square root, so I can put these together. All right, so I'm multiplying, so that means I'm going to be adding exponents. 80 and 50. Think about what if we multiplied those together. 80 times 50 is 400, and hopefully you recognize 400 is a perfect square. So it's beneficial to me to go ahead and multiply the 8 times 50. It just depends on the problem. Sometimes you don't want to multiply them together if you can simplify them separately. So 8 times 50 is 400, x to the 8th power, y to the 6th power. All right, let's change it to a rational. So I got 400 to the 1st power, x to the 8th power, y to the 6th power, all to the 1/2. Apply my properties. So 400 to the 1/2, x to the 8/2, y to the 6/2. Well, the square root of 400 is 20. X, that can be x to the 4th, and then y to the 3rd. So that means we have nothing left underneath the radical. So we don't have a radical in that problem. We have nothing to put underneath the radical. Okay. All right, moving on. All right, look at the following question. This one actually can have two different answers depending on how you're going about solving it. All right, if we do it like order of operations here, and we take the 4th rate, if we go -2 to the 4th power, that's going to be a positive 16. And then the 4th root of positive 16 is 2. So we can get an answer of positive 2. However, if we change the order and rewrite like properties and rewrite this as a rational exponent, all right, apply our properties here, you're going to get negative 2 to the 4 over 4, which is negative 2 to the first power, which is negative 2. So here, either answer is correct depending on how you go about doing the problem. Not one is not more correct than the other. And depending on how you put it in the calculator, you're going to get a different answer too. Okay, so just be cautious of something like that. That's where things kind of are weird because we can get two different answers that are both correct. Okay, let's look at another one. Let's putting all this stuff together. Alright, so when I see this problem, I see two things. I see a negative exponent out here that I take care of, and I see that I can simplify inside. So I like to get my things down as small as possible before I start messing with them. So I'm going to deal with simplifying inside the parentheses first. Alright, so what do I get here? Well, this is like a negative 1, so this is going to give me negative 2 subtract x to the first power y to the third power, all to the negative 2. Alright, that negative 2 is telling me that I'm going to flip this thing over. So this is going to become negative, whoops, going to flip the thing over. I didn't flip. Let's go back again. Flip it over. So I'm going to make this y to the third negative 2x now to the squared. Now I've got to square everything. So just because I flipped it, I still haven't squared it. The negative exponent just tells me to take the reciprocal. Alright, apply your properties. We're going to have y to the 6, negative 2 squared is positive 4x squared. So there's my final answer. So don't forget, negative exponents means to take the reciprocal. Alright, the last thing we're going to do is rationalizing our denominators. So here again, we rationalize, write down my bullet points. We're going to rewrite with rational exponents. If possible, we need to rewrite our numbers with lowest basis. And then we're going to rationalize and simplify. Alright, so let's look at the problem. This is not on your notes, but let's look at the problem from geometry. You had to rationalize something like 3 over the square root of 2. We've been doing this with square roots. We're just changing our indexes now. Let's think about this as an algebra 2 question. We're going to rewrite this as 2 to the 1/2. Alright, my goal is to get this exponent to be a whole number. So I want to just, like I said, I'm going to multiply by a monomial to make this exponent a whole number. So that means what? I'm going to keep the same base. 1/2, the next whole number to 1/2 is 1. So that means I need to add another 1/2. And if I write it over top of itself, it's 1, so it's a multiplicative identity, so I'm not changing anything. So now when I go to write this back, I'm going to get 2, this is the square root of 2, over, this is 2, 1/2 plus 1/2 is 1, so that's why my answer was 3 square root of 2 over 2. Okay? Now with square roots, you're always just going to add another 1/2. 1/2 and 1/2 make 1. But now what we're changing in our algebra 2 world now is that index is not going to be a square root anymore. So like in this problem, we have the 5th root. Alright, now 16. 16 you should recognize we can break this down. So let's do that. Let's break down 16 into 1 over, I'm going to make this to the 1/5 power, okay, because that's 5th root. Break down 16, lowest base. Lowest base is 2 to the 4th power. This is going to, if you realize, this is going to save you having to simplify something later on. Okay, so this makes it 1 over 2 to the 4/5. Alright, now I got to think, I got to rationalize, because this is a less than 1, 4/5, so it's a radical in the denominator. I'm not allowed to have a radical in the denominator. So I need to say, okay, what is the closest whole number to 4/5? Alright, which is 1, right? So what do I need to make this denominator 2 to the, I want 5 over 5, because I wanted that to be 1. Well, that means I need another 1/5. So I'm going to multiply times 2 to the 1/5 over 2 to the 1/5. Why am I doing that? When I add these together, I'm trying to get 1, or a whole number. Sometimes 1, it doesn't have to necessarily be 1. Alright, so let's clean this up. Up top, I'm going to get 2 to the 1/5. On the bottom, when I add 4/5 and 1/5, I get 5/5. Alright, change it back to a radical. So this is the 5th root of 2 over 2 to the 1st, which is 2. So now it's rationalized. Just be careful when you have numbers that you see if you can rewrite with lowest basis. That's the only way you're going to get them simplified as much as simplified completely. All right, one last problem for today on these notes. Let's look at with variables. All right, so here again, I'm going to rewrite this with rational exponents. So that cube root is going to become to the 1/3 power. Apply my properties. So I've got a to the 2/3 over b to the 1/3. All right, I can't have the b to the 1/3 in the denominator, so I got to rationalize this. What's the closest whole number to 1/3? Well, it's 1. So I want this to the 3/3 power. So what do I need? I need a b to the 2/3. B to the 2/3. All right, let's write it back as a rational. So this is a to the 2/3, b to the 2/3. All right, my final answer has to be in radical form. So that we have still cube root, a squared, b squared, all over b. Now, if these had been improper fractions, something would come out and some part would stay in. So that still applies to these. I'm just showing you how to rationalize the denominator. Let's change a problem real quick. All right, let's suppose I had, I don't know, a to the 2/3 over b to the 5/3. Okay? What if this is an improper fraction on the bottom? So what would I do with this one? I still want to get the whole number. What's the next highest whole number to 5/3? Well, hopefully you say 2, 6/3, right? 6/3 makes 2. So what do I need? I've got 5/3, I want 6/3, so what do I need? I need b to the 1/3, b to the 1/3. So now up top here, I'm going to get what? A to the 2/3, b to the 1/3. So this simplifies to what? The cube root of a squared b over b squared. So that's my final answer. Okay? But here again, I want you to, just like I said, notice that you're not always multiplying by the same exponent. Here, you got to think of what's going to make this a whole number. All right, like I said, if anything doesn't make sense, please, we'll talk about it in class. We'll do some problems in class and ask questions.